Good morning, my dear friends. So now, today we shall go to another problem. Okay, I will read this thing now. Problem: a simply supported PSC beam of rectangular section 30 30 centimeter by 50 centimeter is pre-stressed by a parabolic tendon with with a pre-stressing force of 375 kilonewton. Okay, in sense it is pre-stressed with 375 kilonewton. Okay, the tendon has a sag of 25 by 3 centimeter. Okay, at mid span, in sense it has got a sag of 25 by 3 centimeter. Okay, find the extreme fiber stresses by load balancing concept. Okay, this time he has asked you to find out the stresses by load balancing concept. Okay, if it is subjected to first one, a total UDL of 40 kilonewton. In the first instance, he has applied a total UDL of 40 kilonewton, and B, a total UDL of 62.5 kilonewton. In the second instance, he has put a total UDL of 62.5 kilonewton. Okay, the span of the beam is 6.25 meter. So he has given all these data. Okay, so now this thing is now is like this. Okay, the beam is now 300 mm by 500 mm. Okay, so I think you can easily find out YT and YB and all. Okay, and this cable has got a central sag of 25 by 3. It is called H, central sag. Okay, of 25 by 3 centimeter. Okay, so now span of the beam also he has given it 6.25 meter. Okay, so now we shall start calculating the required things now as usual. Okay, so now I would like to calculate this solutions. So now H is equal to 25 by 3. Okay, or it is 8.33 centimeter, or I can call it as 83.3 mm. Okay, this is one thing, or 0.0833 meter. Okay, this is the central sag H, and area of the cross section can also be easily found. It is 300 mm by 500 mm, so it is so much. And moment of inertia also can be now easily calculated. It is BD cube by 12. Okay, B is 300, D is 500. Okay, divided by 12. Okay, so it is so much. So but now what we have seen in case of your this thing is now what now load balancing concept is. Okay, so but now we have seen that at every changeover, at every change in the direction of the cable, okay, this pre-stressed concrete beam produces an upward thrust like this. Okay, so since in case of your pre-stressed concrete beam where the cable is laid parabolically, at each and every point it is changing the direction, so it is producing an upward thrust, and the intensity of this upward thrust, as you know, it is given by P is equal to 8Fh by L square. Am I right, sir? Now this is what we have seen it. It is upward thrust developed in this system is now 8Fh by L square. So now we'll try to calculate it now. Okay, so this P is equal to 8Fh by L square. Okay, see now F I know it is 375 kilonewton. To convert it into Newton, it is so much. 8 is 8, and H, the sag, you have seen that it is 0.0833 meter. Okay, so divided by L, span is now 6.25. So it is now 6400 Newton per meter. In the sense, what it indicates is now, okay, the upward thrust developed in the beam here in the form of UDL, it is 6400 Newton per meter. This is the upward load that is going to be produced when you apply a pre-stressing force of 375 kilonewton. Okay, this is the first thing you have to understand. And now we'll see what he has asked. In the first instance, he has asked when the total UDL of 40 kilonewton is now acting. Okay, in the first instance, 40 kilonewton total UDL is now acting. Okay, so now we'll try to see now. See now. So it is to find out the stresses when a total UDL of 40 kilonewton is now acting. Okay, so now 40 kilonewton means it is 40,000 Newton. Okay, therefore, Baba, it is the total load which is now acting. Therefore, I want to convert it into external load per meter length. So W is, Baba, it is 40,000 divided by span will give me the UDL in a Newton per meter. Am I right, sir? Now, so total load is this, and the span of the beam is 6.25. So it will give me 6400 Newton per meter as the UDL which is acting on the beam, okay, externally, 6400 Newton per meter. So now on the beam this much load is now acting, and just now we came to know that because of the application of this pre-stressing force of 375 kilonewton, we came to know that the upward thrust developed is also now 6400. Just now you have seen, okay, is it right or not? Now P value has worked out to be 6400. In a sense, upward thrust developed is 6400, and downward UDL which is applied is also now 6400. In the sense, externally applied load is exactly counterbalanced by this upward thrust which is going to be developed by the pre-stressing force. So now I say that upward load and downward load are going to be balanced. Am I right now? In sense, downward load is exactly balanced by your upward thrust developed. Therefore, the beam is now subjected to a stress of F by A. So the stress developed in the pre-stress concrete beam is now, it is just simply F by A. So it is F is and area also it is 2.5 Newton per mm square. So 2.5 Newton per mm square at the top, Ft as well as Fb. Okay, this is the stress distribution diagram when a total load of 40 kilonewton is now acting on the beam. Okay, so this is the first answer for this A. Now we will go to B now. Okay, in the second instance, he has asked on the beam a total UDL of 62.5 kilonewton is now acting now. On the beam, 62.5 kilonewton load is now acting. Again, now I want to convert it into UDL. So now UDL external load per meter length W is given by 62.5 into 1000 to convert it into newtons divided by the span. So it will give me 10,000 Newton per meter. This is the external UDL which is acting downwards now. Okay. So now out of this, Baba, the upward thrust developed by the pre-stressing beam is 6400. Am I right? So 10,000 minus 6400 will give me the net downward load W dash. Am I right now? Net downward load W dash is W minus P. W is 10,000 now, and P is the upward thrust which is going to be developed. So now it will give me 2600 Newton per meter. But now this is the load UDL, okay, which is going to produce the bending moment in the beam. So now I want to now calculate that bending moment produced due to this net downward load W dash. Okay, so M is given by W dash L square by 8. W dash it is 3600. Span also okay, 8 is 8. So now it will give me so much Newton meter or so much Newton mm. Okay, so now because of this, okay, that extreme fiber stress due to this moment is given by M by I by Y. M by I into Y. Okay, M M is this, Y is the YT or YB, it is now 250 divided by I is so much. So it is 1.4. Okay, so along with this, F by A term is also now there now. F by A is there now. Okay, F by A is so much. So now when I add them algebraically, both, okay, it will give me Ft and Fb. Okay, I will add them algebraically so that it will give me 3.9 plus it is compression, 1.1 it is a plus, again it is compression. So now this is the stress distribution when a load of 62.5 Newton per load is now acting. So now I can draw the stress distribution diagram as 3.9 on the top, bottom it is now 1.1. Okay, this is how the load balancing concept, the problems can be solved by using load balancing concept. Okay, thank you very much, my dear.